Welcome back, mathematicians. In this lesson, we're diving into composition of functions, how to combine two functions so that the output of one becomes the input of another. I know that sounds like gibberish, so don't worry, I'm going to explain exactly what that means and especially explain how this is fundamentally different than function operations. In another video, I explained how to do operations on functions. If you don't know how to do that, you might want to pause this video and start there first because it gets you more familiar with evaluating functions and then also doing operations with functions. In this video, we are again going to do 3 levels, something very basic where we have 2 relatively simple functions and we are taking the composition of each. The next problem is going to get a little bit more challenging as we take the composition between 3 different functions. And then in our final set, we take 2 quite complex functions and find the composition of these as well. So you can think about this video as easy, intermediate, and challenge. If you want to skip to any of these specific examples, you'll find the chapters in the description below. Let's get started with the basic level. So first, let's talk about what this looks like. This is not fog, although it does look like the word fog and goth. We actually would say f of g of x. We can actually rewrite this as f of g of x. What it means is, instead of the x, we are going to plug what g of x is equal to right in everywhere we see x. So we're going to start off by copying our function down, and everywhere there's an x, we're going to leave a good gap in the parentheses, as if we put parentheses around the x itself, just like this. Then we're going to get rid of that x, and we're going to put the entire function of g inside. So this is f of x squared minus 1, or f of g of x. And so we're going to put x squared minus 1 into each example. That's going to give us 2 times x squared minus 2 plus 3. And when we simplify that, we're going to get 2x squared plus 1. And we're done. And this is considered f of g of x. Now let's do it the other way around. Because the g comes first in this example, it means that we are taking f of x and plugging it in anywhere we see an x in the function g. So the first thing we're going to do is copy our g function down, and everywhere that you see an x, we're going to put parentheses around it, as if we had parentheses with lots of spaces. Then we're going to erase the x, and this time we're going to put the function f of x right inside of here. So we have 2x plus 3 and 2x plus 3. And now we're going to simplify. Remember that a squared on the outside of the parentheses means there's 2 copies of what's inside that parentheses, which means we have to write 2x plus 3 2 times. And not forget that there is a negative 1 tagging along at the end. Now you'll notice that I'm migrating my equal sign over, and that's because I'm anticipating needing a lot more room once I multiply this. So 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. And 3 times 3 is 9. If that was confusing at all, make sure to pause the video and go watch my factoring quadratics and multiplying polynomials video, and then you can come back here. There isn't another 4x squared. We have 2 x's, so 6x and 6x make 12x. And we have 2 constants, numbers that don't have a variable. 9 minus 1 is 8. And this is my g of f of x. Let's move on to the intermediate level equations. In this example, we're just given a third function. It's not actually more challenging because I haven't nested 3 of them. While it is possible to nest 3 of them, you don't see it very often in homework or quizzes or tests, just because it's just a lot of work of exactly the same thing. It's really considered busy work. If you do happen to have one, though, that you want worked out, feel free to mention it in the comments below and I can try to help. So in this case, we have f of x as a function, g of x as a function, and h of x as a function. And you'll see we have slightly more challenging functions with a little bit of different elements. The first one we're going to do is actually exactly like the last one, where we're taking that function g of x and we're plugging it in everywhere that we see x inside of the f of x function. So the first thing we're going to do is copy down our f of x function with really big parentheses around the x, so we have plenty of space for another function. Now this one, I know that g of x is also stacked vertically, so I'm not just going to give some space. In fact, if I had been wise, I would have started like this. And then plus 2, all still inside of the square root. We're going to erase our x, and I'm going to squeeze 1 over x minus 1 here, and 1 over x minus 1 here. So now this probably looks a little confusing. How are we going to tackle that fraction inside of the radical? Remember that in order to add fractions together, we have to find common denominators. So we can do a little bit of side work here where I pull these 2 fractions out, and you might be saying, well, that's not a fraction, and you'd be right. But all whole numbers, remember, can be turned into fraction by putting them over 1. Now we're going to do cross multiplication. We're going to multiply 2 times the entirety of x minus 1. So we have 2x minus 1. And then we're going to multiply 1 times 1, which is 1. And we're putting that all the way over the combination of these 2 denominators. So we're going to multiply across this way. 1 times x minus 1 just gives us the common denominator of x minus 1, just like this. Now we have to remember that that has an entire square root over it, and that this was our little bit of side work just to be able to find a common denominator. Well, what we can do at this point is start to simplify. From here, we can distribute that 2 into this parentheses. So I'm going to move down here. 2 times x is 2x. 2 times negative 1 is negative 2 plus 1. And we still have x minus 1 on the bottom. Now when I combine like terms here, I get 2x minus 1 over x minus 1. And this is actually my final answer. It can't get any more simplified than this. We could write it in exponential form, but there's not a reason to. It doesn't help us. And so this is our f of g of x. All right, on to the second equation. This function says we're going to find h of g of x. So we're taking g of x again and plugging it into the function h. So let's copy h down with an x in a giant parentheses like last time. This has a giant parentheses here. And this, oops, I forgot my 3, is going to have a giant parentheses here. And in fact, I might go ahead and shift this over so I have a little bit more room. Everywhere that we had parentheses is where we had an x. And because I know that this is a vertically stacked function, I left myself a lot of extra room to fit in here, just like this. Now this is getting quite complicated. I have 2 copies of 1 over x minus 1 squared. And then I have a 3 that needs distributed in here. Now this is actually quite easy. We're just going to put the 3 on top, like this. Now, in order to be able to add these two together and simplify, we need to have 2 copies of x minus 1. You can see that this only has 1 copy of x minus 1. So we're actually going to come right in here and we're going to create the common denominator in a slightly different way than we did here by multiplying the top and bottom by the thing that's missing. So here we can go ahead and multiply those together. 1 times 1 is 1, plus 3 times x minus 1 is 3x minus 3. And now I know this is all over 2 copies of x minus 1, so I can actually write it with a squared, like this. I'm going to combine like terms here. There aren't any other x's on top, so I have 3x. 1 minus 3 is negative 2, and that's going to be all over 2 copies of x minus 1. And this is my final answer. So to give myself just a little bit more room over here, let's shift it over. We probably need to use 2 slides for the next challenge problem. This is h of g of x. Let's move on to that challenge problem now. So I've gone ahead and shifted things around just a little bit on this slide. I am going to do g of x on the next slide here, or g of f of x, but we're going to leave lots of space for ourselves on this slide first. Now remember that f of g of x means that we're taking the function g of x and plugging it into the f function. So we're going to come right over here and make a giant square root sign and put parentheses around every x, and we're going to go ahead and put in another giant fraction, 3x plus 1 over x minus 4. And that has minus 2 on top, all over, again, 3x plus 1, all over x minus 4, with a plus 1 on the bottom. Now, we have to find our common denominators. This is missing x minus 4 on the top and bottom, so I'm going to put this over 1 and multiply x minus 4 on the top. Now we have to be a little bit careful with this because this is a negative 2. So I'm going to just copy my first fraction, remembering that we've got the whole thing in a square root symbol. I'm going to copy my first fraction down as I see it, like this. And then I have negative 2 times x, which is negative 2x, and negative 2 times negative 4, which is positive 8. And that's going to be all over the denominator, x minus 4. Now let's simplify the bottom. This is also missing an x minus 4. So we find a common denominator. And I just want to point out that this isn't the only way to do it, but this is the most straightforward way. 3x plus 1, and then we're going to distribute this one into the parentheses. And we're putting this one all the way over x minus 4. Now I'm going to remind you that fraction signs are really hidden division signs. And remember that when you divide by another fraction, you're really multiplying by its reciprocal. So we could actually come right up here, get rid of this whole function on the bottom and put it upside down in a multiplication problem instead. And so that's what I'm going to do here. Now, I didn't simplify it yet, but we're going to do that in our next step. So we're going to come down here. Remember, it's all under our radical. And we have 3x plus 1 minus 2x plus 8. So 3x's minus 2x's leave a single x. 1 plus 8 leaves 9. And x minus 4 and x minus 4, the handy thing about this now is that anything over itself can be canceled out. Because this is multiplication, we can think about it like this, like they're right on top of each other. And that turns into the number 1, so we can cancel it out. On the bottom, we have 3x and x makes 4x, and 1 minus 4 makes negative 3. So you can see because of all the simplification, I didn't actually need this giant square root. But now this is my final answer. It doesn't get any more simple because I can't factor anything out of either the numerator or the denominator. And so this is f of g of x. Okay, we've done tons of work. Let's move on to the next problem. So now we're going to do the reverse of this. We have the function g, and we're going to insert the function f of x everywhere we see an x. So we're going to start off by copying the function g down. And I notice that this is also very vertically stacked with a radical, and we have x minus 2 and x plus 1. Now you might be wondering why I'm writing a parentheses anyway, even though we have a radical, and that's because if I were to write it like this, you might think this is a cubed root, and it's not. It's 3 times this square root. And here we have plus 1. On the bottom, we have x, so we need this giant radical down here, x minus 2 over x plus 1. And this is subtracting 4. So the one thing that I want to point out here, and we can go ahead and do a little shifting before we actually multiply things out. If we put our 3 out here with a multiplication sign, we can kind of get rid of these parentheses and begin to work with the numerator. Now what I mean by that is, remember that in radicals, if you have a fractional radical, let's say it's x over y, you can rewrite that as the square root of x over the square root of y. These two things mean exactly the same thing. So I'm going to make life on us just a little bit easier, and instead of having a giant radical, I'm going to break this up into 2 smaller ones, so it looks like a little bit more of a manageable fraction. We're going to do exactly the same thing to this one down here as well, just like that. Now it's a little bit easier. Not only do we have a little bit more room, it's a little bit cleaned up, but it's a little bit easier to see how I can make common denominators here too. So on the bottom here, I am missing the square root of x plus 1. So remember that this is a fraction, and I'll have to put the square root of x plus 1 over the square root of x plus 1, like this. And here I am also missing the square root of x plus 1. So we turn this into a fraction and multiply it by itself over itself. All right, here comes a little bit of simplification. Let's move this guy out of the way. Actually, we might go ahead and get rid of him. We have 3 times this fraction, so that 3 is now going to migrate to the numerator. So we have 3 times x minus 1 plus the square root of x plus 1. And that's going to be all over the square root of x plus 1. On the bottom, we have the square root of x minus 1 minus 4 times the square root of x plus 1. And that's going to be all over the square root of x plus 1. Just like last time, remember that when you are dividing two fractions or anything, a fraction sign is a little hidden division sign, and we can turn that into a multiplication problem by bringing it up here and taking the reciprocal. That means we're going to flip it upside down. So on the top now, we have the square root of x plus 1. I'm anticipating running out of just a little bit of room, so I'm going to shift it over. And on the bottom, we have the square root of x minus 1 minus 4 square root of x plus 1. So just like before, since we have the square root of x plus 1 on the top and the square root of x plus 1 on the bottom, we can cancel both of those out. You might be thinking that you could put these together in some way. You cannot, because this is a negative and this is a positive. And so we are simply going to rewrite our final simplified answer down below. So this is going to be 3 times the square root of x minus 1 plus the square root of x plus 1 over the square root of x minus 1 minus 4 the square root of x plus 1. Now, I had a student recently ask me this question, and I think it's a fantastic question. She said, this is the square root of x plus 1 over the square root of x plus 1. Can't I cancel these out? Couldn't I cancel these out? And at first, it might look that way, but you have to be very careful because they are separated by an addition and a subtraction. That makes these two separate terms. And so the entire top, the numerator, would have to look like the entire bottom, the denominator. Since they're not exactly the same, they cannot be canceled in any way. And it's these stinky operations in between that have stopped us from being able to do that. So this is our final simplified form of g of f of x. And we're done. Congratulations, getting through all of this complex function, composition of function, and operations. If you have any questions, make sure to comment below and like and subscribe.